So you have learned the essentials of Angular. Every application needs to be deployed at some point, and that's the topic for this section. So you're going to learn how to optimize your applications for deployment, build deployable packages of your app with Angular CLI, work with different environments like development, testing, and production, lint your code to keep it clean and consistent, and deploy your apps to GitHub pages, Firebase, and Heroku. So now, let's get started. In this section, we're going to deploy a very simple application I have built that you can download from this lecture. So if you want to code along with me, download the zip file, extract the project, and just like always, run npm install, and then ng serve. So this is our application. We have a couple of pages. One is the home page, and the other is the list of my followers on GitHub. So this application includes routing and consuming HTTP services. So here we have only a front end. Our backend, in this case, GitHub API, is provided by a third party. In your applications, you may build the backend yourself. So later in this section, I will give you some directions about how to deploy both the front end and the back end. Now, in terms of the deployment, here we have a couple of options. The simplest option is to copy this entire folder with all its files into a non-development machine. So I can copy this folder into, let's say, a production machine, and there I can run ng serve. That's the simplest option, but there are a couple of problems with this approach. The first problem is that here we have quite a large number of files. So if you look at this node modules folder, here we have more than 23,000 files, and the total size of this folder is more than 230 megabytes. Sure, we can exclude this folder and do an npm install on the target machine, but there is still another problem with this approach. The problem is that here we have large bundles. So here in the terminal, look at the size of the vendor bundle. Our vendor bundle is 2.5 megabytes, and this is a very simple application. We're not using a lot of third-party libraries. In fact, we're only using Angular. Also, our main bundle is 20 kilobytes, and our styles bundle is 159 kilobytes. We can do much better. So let me show you a few optimization techniques we can apply here. These techniques have been around for more than a decade, and they're not specific to Angular. Chances are you're familiar with most of these techniques. The first technique is minification, and this involves removing all the comments and white spaces. So look at this piece of code here. We have 3 lines of comment, a class with 1 method. If we run this code through a minifier, we're going to get something like this. So our comment is gone, and all the white spaces are removed. So this is minification. We have another technique called uglification, and this involves renaming long descriptive variable and function names into short cryptic names. So back to our example, we can rename our home component and the onClick method to something like this. So this is uglification. Now the good thing is we don't have to do this ourselves. There are lots of tools out there that do this for us. The third optimization technique is bundling, and you have already seen that throughout the course. So when we serve our application using Angular CLI, it automatically creates a few bundles for us. Each bundle is basically a combination of multiple JavaScript files. Without these bundles, if you want to serve our application exactly the way we have structured our code, the client has to send hundreds of requests to download the application. And this is very inefficient. By combining multiple files into a bundle, the client can get a large portion of the application's code using 1 HTTP request. And this means the application loads faster on the client, but it also allows the server to serve more clients. Because instead of serving, let's say, 500 requests from one client, it can serve 5 requests from that client, and at the same time, it can serve several other clients. So this is bundling. The fourth optimization technique is dead code elimination. And this involves removing any code that is not part of the application. For example, you might have created a few classes, but perhaps we haven't used them anywhere in the application. It doesn't make sense to include these classes in our final bundle, so we want to exclude these. Or similarly, if we have referenced a few third-party libraries in our package.json, but we're not using them, we don't want to bring all these third-party libraries in our bundles. So this is dead code elimination. And the last optimization technique is ahead of time compilation. And this involves pre-compiling Angular components and their templates, and this will have a significant improvement in the performance of our application. I'm going to talk about this in the next lecture. Now here's the good news. We can apply all these optimization techniques using a single command with Angular CLI. So when we build our application using Angular CLI with the prod flag, Angular CLI will produce highly optimized bundles. And then we can simply deploy these files to a non-development machine. You're going to see this later in this section. So first, let's take a look at ahead of time compilation. So what is this ahead of time compilation? Well, every Angular application involves a compilation step. So far, you haven't seen this compilation because it happens behind the scene. But I'm going to show that to you in a minute. So in Angular framework, we have a compiler. The job of this compiler is a little bit different from other compilers you might be familiar with. For example, a C++ compiler takes C++ code and converts it to a different language, like machine code. Angular compiler, in contrast, takes JavaScript code and produces JavaScript code. And this might be confusing for you at the beginning, but it's actually very easy to understand. Let me explain it using an example. Look at the template for our home component. Here we have an interpolation string for rendering the title field. If we load this HTML file in a browser, are we going to see the value of the title field? Of course not. We're going to see this as static text, exactly as is. So this curly brace syntax is only meaningful to Angular. The same is true for all the property and event binding expressions. Browsers don't understand that. It's only Angular that understands what these property and event bindings mean. So when our application starts, Angular compiler is going to kick in. It's going to walk down the tree of our components, and for each component, it's going to parse its template. So in this case, it's going to look at the template for our home component. It sees that here on the top, we have a div. Inside this div, we have an h1, and inside this h1, we have some static text, plus some dynamic text and interpolation strings. So based on this template, it's going to produce some JavaScript code to create this structure in the DOM. So here's an example. This is a very simplified example. When Angular compiler parses the template for our home component, it may produce some JavaScript code like this. So here we create a new element using document.createElement. This is our div. Then we create an h1, and next we append this h1 as a child element inside this div. Now after this, there's going to be some code to take the value of the title field from our component and display it in the DOM. And also there's going to be more code for detecting the changes in the value of this field and refreshing the DOM if necessary. So Angular compiler will produce this JavaScript code at runtime. And then this code will be executed, and as a result, we'll see the view. This is what we call just-in-time compilation. In other words, the compilation that happens at runtime. Now, this just-in-time compilation is perfectly fine when we are developing an application on our local machine, but it's very inefficient for a production environment because this compilation step is going to happen for every user of our application. So every time a user lands on our application, Angular compiler is going to walk down the tree of our components and compile all these components and their templates. Now you can imagine, as the number of our components increases, or as our templates get more complex, this compilation step is going to take longer. Also, for this very reason, we have to ship Angular compiler as part of the vendor bundle. And this is why our vendor bundle is 2.5 megabytes, even for a simple application. because almost half of this bundle is dedicated to Angular compiler. Now, what's the solution? Well, we can perform this compilation step ahead of time before deploying our application. Then this compilation step doesn't have to happen for every user. Our users will download the final pre-compiled application. And this means our application will start faster. So the browser doesn't have to wait for the Angular compiler to compile our application. Also, we no longer have to ship Angular compiler with our vendor bundle, and this will reduce the size of this bundle significantly. Another benefit of ahead of time compilation is that we can catch all the errors in our templates earlier at compile time before deploying our application. In contrast, with just-in-time compilation, we see these errors at runtime. But if you have a complex application with a lot of pages, we may not be aware of the errors in our templates until we navigate to a particular page in our application. In contrast, with ahead-of-time compilation, we can catch all these errors at compile time before deploying our application. And finally, with ahead-of-time compilation, we get better security because we compile HTML templates and components into JavaScript files long before they're served to the client. With no templates to read and no risky client-side HTML or JavaScript evaluation, there are less opportunities for injection attacks. So these are the benefits of ahead-of-time compilation. Next, we're going to see this Angular compiler in action. All right, now let's see Angular compiler in action. So if you open up package.json, under dev dependencies, look, here we have a dependency to angular/compiler-CLI. This is the Angular compiler package that takes a significant part of our vendor bundle. Now let me show you how to run this compiler. So here in the terminal, we can run Angular compiler from node modules folder. So node _modules .bin, that's where the binary files are located. And here we run ngc, that's Angular compiler. Now let's see what happens. All right, Angular compiler compiled our components and their templates. Now back in VS Code, you can see we have 25 new files here. Here is an example. In the home folder, next to our CSS file, you can see we have a new file, .shim.ngstyle.ts. Let's have a look. So currently we don't have any CSS for this home component. That's why this array is empty. But if we did have any styles, Angular compiler would export these styles using a constant here. Let's take a look at another example. Back in the home folder, we have this file, home.component.ngFactory. So for every component that we have referenced in our application, Angular compiler generates an ngFactory file. Look at this code here. This is the combination of our component and its template. So you can see a little bit of our markup here. So earlier we had this text align center applied to our div in our home component. Here we have an image. You can see the source attribute of this image. So this is the code that Angular compiler generates at runtime. And of course, this is TypeScript, so it should be transpiled to JavaScript and then it will be executed. And the result of this is our home component rendered in the DOM. Now, as you can see, this code is very cryptic, so it's not designed, it's not produced for humans to read. I just wanted to show you what is happening at runtime when you load an Angular application. So Angular component kicks in and it generates a bunch of ngFactory files for each component referenced in our application. Now let me show you something interesting. I'm going to go to home.html and change this title to title 2. Obviously, we don't have a field with that name. So now let's see what happens when we run Angular compiler. Back in the terminal, I run ngc. Here we get a compilation error. Property title 2 does not exist on type home component. So this is the benefit of ahead of time compilation. We can catch the errors in our templates earlier. Now, in the real world, we don't have to run ngc like how I showed you here. This was purely for demonstration. Instead, we're going to use Angular CLI to build our application for production, and Angular CLI will internally run Angular compiler. And that's what I'm going to show you in the next lecture. In this lecture, I'm going to show you how to use Angular CLI to build your applications and get deployable packages for production. With this, you will get all the optimization techniques that I mentioned at the beginning of this section. First of all, I want to delete all these 25 files that were generated in the last lecture as part of running Angular CLI. We don't want any of these files in our project. So, undo, discard all changes. Now, back in terminal, in order to build our application for production, we run ng build with the prod flag. And this will create a deployable package that we can simply copy paste to a different machine or use FTP or any other mechanism to deploy to a production server. But before running this, I want to show you what happens when you run ng build without the prod flag. So delete. This is going to take a few seconds. Okay, we got those 5 bundles just like before. You can see our vendor bundle is still big. It's 2.2 megabytes. So we don't have ahead of time compilation here. In other words, Angular compiler is part of this vendor bundle. Now back in VS Code, you can see this new folder here, dist, which is short for distributable. Let's have a look. So we've got the favorite icon for our application. We've got the glyph icon files, which are part of Bootstrap. We've got index.html and our bundles. Now I want to show you a few things here. First, let's take a look at this index.html. This index.html is slightly different from the index.html that we have in our source folder. So here in the body element, after app root, we have a few script references. So the first one is a reference to inline.bundle.js. After that, you can see a reference to polyfills and other bundles in our application. In contrast, the index.html that we have in the source folder doesn't have any script references. Let's have a look. So we go to index.html in the source folder. Look, here in the body element, we don't have any script references. Because during development, these bundles are injected into the body element at runtime. Okay? Now back to the dist folder. For every bundle, we have 2 files. One is the actual bundle file, and the other is a map or a source map file. The purpose of this map file is to map a piece of JavaScript code in the bundle to its original source file. So when you're debugging our application in Chrome, this map file allows Chrome debugger to show you the actual code in the source file, not in the bundle. Okay? Now let's take a look at one of these bundles. You can see here we don't have any of the optimization techniques I told you at the beginning of this section. We have all these kinds of comments. We have a lot of white space. We have long descriptive names. So we don't have minification or uglification. We also have dead code. So if you have created components and services that we have not used in our application, they will end up in these bundles. Let me show you an example. So I'm going to create a new component. Let's call this courses. And I'm not going to use this anywhere in our application. Okay? Now I'm going to build the application one more time. So ng build. All right, our bundles are ready. Now let's take a look at this main.bundle.js. So here, if you search for courses, you can see 27 references. So all the code for our courses component is in the bundle. So we have dead code here. Also, here we don't have ahead of time compilation because the Angular compiler is included in the vendor bundle. Now let's see what happens when we build the application with the production flag. So ng build -- prod. Now look at the size of our vendor bundle. It's 1.2 megabytes. So it's almost half the size. But by the way, this is the initial size before applying any kind of minification and uglification. So if you look at the actual file size, it's even smaller. Let me show you. So let's have a look. I'm going to show you the vendor bundle in the dist folder. Look at the size of this file. It's 325 kilobytes. So we reduced this from 2.5 megabytes initially to 300 kilobytes. Also, if you look at the other bundles in our application, they're all smaller. Now back in the dist folder, we've got this favorite icon and glyph icons just like before, but look at this index.html. You can see we don't have any white space here. So all our HTML markup is represented as one long string. Now let's take a look at one of our bundles. So this is the inline bundle that you saw earlier. You can see we don't have any comments here. We don't have any descriptive identifiers. So our function names, our variables, they're all cryptic, like E, R, N, and so on. Also, here in the file names, we have this random string that we call a hash. This hash is generated based on the content of the bundle. And it's a technique to prevent caching. So every time you modify your code and regenerate these bundles, this hash is going to change. And this will prevent the client's browser to cache a file with the exact same name, because the name of the file is going to change in each build. So to recap, we can use Angular CLI to build a deployable version of our application. And what we get is this dist folder. You can simply copy paste this folder into a non-development machine. You can use FTP, or in a more advanced scenario, you can set up some kind of continuous deployment workflow. In a typical web application, we have the concept of environment. So quite often, in most organizations, we have three environments. We have the development environment, which is used by developers. We have the testing environment, which is used by testers, and the production environment, which is where we deploy our application. Earlier in the course, we had a quick look at this environments folder. This is exactly to implement the concept of environments for our application. So now let's take a closer look at what we have here and how we can define additional custom environments. In this folder, we have two files: environment.prod, which is for production, and environment, which is used for development. Let's take a look at environment.ts. So here we're simply exporting an environment object with one property, production. Here we can have additional properties. For example, you may want to change the color of the navigation bar depending on the environment. This way, testers know that they're looking at the actual testing website, not the production website, so they don't accidentally modify some data in the production. Or you may want to change the name of the application in the navigation bar. You may want to add the word testing. Or perhaps you want to use a different API endpoint in your testing environment. You can add all these properties in this object. For example, I'm going to add navbar background color. So in my development environment, I want to make this blue. Now we should add the same property in our production environment. So let's go to environment.prod.ts and simply paste this property, but change the color to, let's say, white. Now back in the other file, you can read from this comment that when you build your application using Angular CLI and supply the environment flag, Angular CLI will pick one of these environment files and put it in our bundle. So we don't have to write any code to work with a specific environment object. Let me show you what I mean. So let's go to our navbar component. Here I'm going to define a field called background color. And I'm going to set this to the navbar background color of our environment object. So environment, auto import, look on the top. Here's a problem. Our auto import plugin specifically imported the production environment, and this is very dangerous. We don't want to use this. We want to use environment, and then when we build our application, Angular CLI will either pick this environment or environment.prod, depending on the environment we specify during building. So make sure to always import from environment. Okay. Now we set this background color to environment dot look. We've got these properties here. So let's set it to navbar background color. And then let's go to navbar.html. Here on this nav element, I'm going to apply a style binding, style.background color. I'm going to bind this to the background color field in our component. Now, if you want to see this in action, you don't necessarily have to build your application. You can still serve your application with ng-serve, but additionally, you need to specify the target environment. So when we run ng-serve, here the target environment by default is development. If you want to load your application in the production environment, you can add --prod. This is the short form for adding environment equals prod. So now Angular CLI is going to build our bundles using the production environment object. So back in the browser, you can see our navigation bar is white. But if you go back here and run ng-serve, now we're going to be in the development environment and our navigation bar is going to be blue. So back in the browser, look, this is our environment object in action. Hi, thank you for watching my Angular tutorial. If you enjoyed this video, please like it and share it with others. Also, you can subscribe to my channel for free new videos every week. This video is part of my complete Angular course with almost 30 hours of high quality content where you will learn everything about Angular from the basic to the advanced topics all in one course, so you don't have to jump from one tutorial to another. In case you're interested, you can get this course with a big discount using the link in the video description. And if not, that's perfectly fine. Continue watching as the next section is coming up.